Hi, today I'm going to go through AQA's AS Level Maths Paper 2, the Pure and the Statistics from 2019. So I'm going to start with the Pure Maths, Part A. So here we go. Question 1. Find the gradient of a curve y equals e to the minus 3x at the point where it crosses the y-axis. Okay, well the y-axis is where x is equal to 0. Okay, the curve's going to look y equals e to the minus 3x. That's a decaying curve, so we want to find the gradient here. And we can see it's going to be negative, so that means it's minus 3 or minus 1, so which is it? Well, how do we find the gradient? We differentiate. So if we differentiate that, by applying the chain rule, the derivative of the inner function minus 3x is minus 3, which comes to the front, so, and the exponential just differentiates to itself. So minus 3 e to the minus 3x. So if we evaluate that at x equals 0, we get minus 3 e to the 0, which is just minus 3. Question 2. Find the centre of this circle. The idea here is where you're given a circle in this form is to complete the square. So I'll just rearrange the terms like this, put the x terms together and the y terms together. And then what we do when we complete the square is we look at the linear terms and we put half of that coefficient inside of the square. Because if I was to expand that again, I would get x times 2 and 2 times x, so I get 4x back. But I'd also get 2 squared, which is 4. So I need to subtract that off so that I've got the same as I had originally. So x squared plus 4x can be written like that. Similarly for the y part, the coefficient of the linear term is minus 6. So I'm going to have half of that, which is minus 3 there. And then minus 3 squared is 9, so we need to subtract that off as equal to 12. So if we just rearrange that, move the constant to the other side, 12 plus 4 plus 9 is 25. So this represents a circle with a centre at, well, generally, the equation of a circle is this, so the centre would be at A and B if that was the case, and have a radius r. So x plus 2, that's x minus minus 2. So the centre must be at minus 2 and 3. So it's that one there. Question 3. We're told that sine theta has a value of minus 0.1 and that the angle is between 180 and 270. Find the exact value of cos theta. Well, we know that sine squared theta and cos squared theta are related by the Pythagorean identity. So if we rearrange that, we can say that cos theta is equal to, so take the sine squared across and then take the square root, and it's going to be plus or minus that. So plus or minus the square root of 1 minus, so if sine theta is minus 0.1, then sine squared is just that value squared. So this is plus or minus 1 minus 0.01, so that's 0.99. Okay, so that's 99 over 100. So 100 on the bottom, if we take the square root of that, that's just 10. 99 is the same as 9 times 11. So the square root of that is going to be the square root of 9, which is 3 times the square root of 11. So I get 3 root 11 on top. If you just put it in your calculator, it'll probably simplify to that for you anyway. Now, which is it, plus or minus? Well, this is where we use the unit circle idea. So you may have come across this idea of a cast diagram. So starting from the positive x-axis, where the angle is 0, and going anti-clockwise, then we have this picture which you may have seen, and then back to 360 again, and just keeps repeating and going round. So what this means is that between 0 and 90 in this first quadrant, we have A here. A stands for all. So all of the trig functions, sine, cosine, and tangent, are all positive in that region. So for example, sine between 0 and 90 is positive. Cosine between 0 and 90 is positive, and tangent the same. So between 100 and 270, so that's this region down here, we've got the letter T. So what this means is that only the tangent is positive. So cosine, which we're after, will be negative then. So the answer is that we take the negative sign there. So 3 root 11 over 10 minus. Question 4. Show that if x is greater than 0, then this identity is true. Well, let's work on the left-hand side. Using our rules of logarithms, if we add logs together, we can write that as a log of a product. If we subtract a log, then it becomes a quotient. So we just put all of that together. So I've got x over x to the power of 4 divided by 100, multiplied, not using times signs, it's confusing, times 9x, and then divided by x cubed. Let's simplify inside that bracket. So I've got 9 over 100 first, log of 9 over 100 multiplied by, so on the top, x to the 4 times x is x to the 5, and then divided by x cubed. So that's x squared. So how do I make it look like this? Well, this number here, 9x squared over 100, is just the same as 3x over 10 all squared. Because we can see that we want to bring a 2 to the front. So if we rewrite it like that, then the 2 comes to the front, using another rule of logarithms, and this ratio here will split up again into 2 separate terms. So I've got 2 log base 10 of 3x minus log base 10 of 10. And it's always true that log base a of a is 1. So that last term is just equal to 1. So I get 2 log base 10 of 3x minus 1. Okay, and that's it really. Doesn't really matter about swapping the order of terms. Question 5. A triangular prism has this cross section shown. We're told some angles, one of the sides, and we're told the length of the prism is 300. So just to draw a little picture, so we've got this. So this side is 300, and we've got the rest of the information. So we want to find the volume of this. We know that volume is, for any prism, is the cross-sectional area times the length of it. So what's the area of this shape, this triangle? Well, generally the area of a triangle is a half multiplied by the product of any two sides. So let's pick AC and CB, multiplied by the sine of the angle in between them. So the angle between those sides is 30 degrees. So I've got that, and then multiply by the length. Right, now CB I've got, that's great, but I don't know what AC is, so how do I find that? Well, I can use the sine rule. If I've got two angles, I know that all the angles in a triangle add up to 180. So that allows me to find this angle, which is 180 minus 30 is 150, minus 25 is 125 degrees. So I can say that AC, which I'm going to need, divided by the sine of the opposite angle, which is 25, is going to be the same as BC over sine 125. So AC is BC times sine 25 over sine 125. So I'm going to take that value, substitute it in there, and then just put all the values in. So I've got half of AC, which is BC or CV. Okay, so that's CB squared multiplied by sine 25 over sine 125 times sine 30 times the length. So I've got a half of 40 squared times sine 25 sine 30 or sine 125 times 300. And if I put that all together, I get to three significant figures, which is what I'm asked for, about 61,900 millimeter cubed. Question 6. A curve has this equation, find an area under an axis. Basically, it's just quite simple. So between x equals 1 and x equals a, and we're told that a is greater than 1, so a is to the right of it. So we want to find this basically. First of all, just note that it's written more complicated than it needs to be here. So as just a power of x, we've got divided by x, that's x to the minus 1, and then divided by x to the half. So overall, that's x to the minus 3 halves. And so the area is just from 1 to a, the integral of this function. So let's work that out. So with the power law, we just increase the power by 1, divide by the new power. And then we'll put the limits there. If you divide by minus a half, that's the same as multiplying by minus 2. So I've got minus 4. And then x to the minus a half means 1 over root x. So we've got that. We're just simplifying. So put those values in. So I've got minus 4 over root a minus 4, so plus 4 over root 1, which is 1. And we're told that that is equal to 3. The area has 3 units. So we just need to solve that for a. So we've got minus 4 over root a is equal to 3 minus 4, which is minus 1. So root a is equal to 4, so a is equal to 16. Right, question 7. Okay, it looks a little bit horrendous at first glance because we've got 4 unknowns to find. A, C, D, and E. But let's just do it a bit at a time. And what I would say is a picture is always useful. So what have we got? We've got a circle which has this equation. So going back to what we said in a previous question, we know that if it's written in this form, then the radius is the square root of E, and the center of the circle will be at C and D. Okay, so we've got that bit of information there. We also know that there are 2 points on the edge of the circle, A and B, and they're a diameter of the circle. So they pass through the center, and the point 2 and 4 is also on there. So I'll just put all of that information on the diagram. Right. Where can we start then? Well, first of all, if we look at the gradient of that line, that diameter, so look at the gradient of the diameter AB, we know that that's going to be, if we use point A and point B, delta y over delta x, so 6 minus 3 over 10 minus a. Okay, so we're just using delta y over delta x there. But we could use 2 other points, so we could pick this point that's on the diameter 2 and 4. We could use that in point B. So that's going to be the same gradient as if we chose 6 minus 4 over 10 minus 2. Okay, and then we can use that to find a. So I've got, what, 3 over 10 minus a is equal to 2 over 8. So if we cross multiply that, we're going to get 24 is equal to 20 minus 2a. So 2a equals minus 4, a equals minus 2. Okay, so that's the first quantity. Great. Done. Where can we go next then? Well, with that diameter, we know that the radius was root e. So the whole diameter is 2 root e. So we've got 2 root e is equal to the distance from A to B. And how do we find the distance between 2 points? We use Pythagoras. So we've got the distance in the x values, which is 10 minus a squared, plus the square of the distance between the y values, so 6 minus 3 squared. Okay, let's get rid of the square root by squaring both sides. So if I square the left-hand side, I get 4e. 2 times 2 is 4. And on the right-hand side, it just gets rid of the square root. So I've got 10 minus a, but we know what a was. That was minus 2. So 10 minus minus 2, that's 12 squared. And then 6 minus 3 is 3, so that's 3 squared there. So a is equal to 1/4 divided by the 4 of 144 plus 9. So that's 153 over 4. So that's e. Now we still need to find c and d, but c and d is just the midpoint. I'll do a different colour. So if we use the midpoint of the curve between a and b, that will allow us to find c and d now. So c is just the average of the x values. So it's going to be the average of 10 and a. So a was minus 2, so 10 minus 2 is 8, divided by 2 is 4. And d is the average y value, so the average of 6 plus 3, which is 9 over 2. Okay, there we are, done. Question 8. So we've got some cubic here, and we've got a little bit of information. So we're told that the cubic passes through the point x equals 2, y equals 3. So let's just substitute that straight in. So y equals 3 when x is 2, so 2 cubed is 8, 2 squared is 4, and then plus 2 cubed minus 45. So if we rearrange that to put all the constants on one side and the p's and q's on the other, I've got 4p plus 2q is equal to 3 plus 45, which is 48, minus 8, which is 40. We've also got that the gradient of the curve at r is 8. So how do I find out gradient? Well, we're back to derivatives again. So y primed, the derivative, is 3x squared plus 2px plus q, and then 45 was a constant, so that just disappears. And we want to evaluate that when x is equal to 2. So we get 12 plus 4p plus q, and we're told that evaluates to give 8. So if we rearrange that one, we've got 4p plus q is equal to 8 minus 12, which is minus 4. Okay, subtract, but just simultaneous equations here then. So subtract one from the other. 4p minus 4p is 0, 2q minus q is q, 40 minus minus 4 is 44. Then substitute that back into any equation. So if we just substitute that back into there, we've got p, 4p is equal to minus 4 minus q, so that's minus 48. So p is equal to minus 48 over 4, which is minus 12. Part B, calculate the area enclosed between the normal to the curve and the coordinate axes. Right, well let's find the normal first then. So we know that for a curve, the tangent and the normal are at right angles to each other. And when we differentiated the curve, we found the gradient of the tangent. So what we can write down is that the gradient of the normal is equal to minus the reciprocal of the tangent gradient. So minus 1 over 8. And normal is just a straight line, so let's just write y equals mx plus c. And we also know that it passes through the point 2 and 3. So we've got y equals 3, the gradient is minus 1 over 8, x is 2, so that'll allow us to find c. So c is going to be 3 plus 2 over 8 plus a quarter, so that's 13 over 4. So y is equal to minus 1 over 8, x plus 13 over 4. So what does that look like? Well, it's got a negative gradient that crosses the y-axis at 13 over 4. So basically we're asked to find this area then, between the normal and the coordinate axes, so between the x and y axes. So what we just really need to find then is just the value of this point. Well, that's just the value of the normal when y is 0. So 0 equals minus 1 over 8 x plus 13 over 4. So x is equal to 8 times 13 over 4, so 2 times 13, 26. So this value here is 26. Now you could, if you wanted to, you could integrate the equation of the normal from 0 to 26, but it's just a triangle, so the easier way to find the area is just to do a half of the height, which is 13 over 4, times the base, which is 26. A half of 26 is 13, so I've got 13 squared on top, which is 169 divided by 4. Okay, and that's the area. Okay, question 9 now. We've got another curve, in fact another cubic, and we're asked to find the coordinates of the turning point. So it's coordinates, so we need to find the x and the y values, and then the nature of each turning point. So is it a max, a min, or a point of inflection? Okay, so which is which? Right, how do we find turning points? Well, we know a turning point is where the gradient is 0, so we need to differentiate this function. And how can I do that? Well, I would not recommend multiplying everything out. Just use the product rule. So we've got x minus 2 multiplied by x minus 3 squared. So the product rule tells us to differentiate one part and leave the rest alone. So if I differentiate x minus 2, I just get 1. So I get 1 multiplied by x minus 3 squared. And then if I leave the x minus 2 alone and differentiate x minus 3 squared, that differentiates by the chain rule to 2x minus 3. So I'll put the 2 at front times x minus 3. Now multiply it out. So I get x squared minus 6x plus 9 from the first bit. Then I've got x squared minus 5x plus 6, and then all multiplied by 2, so that's going to give us 2x squared minus 10x plus 12. Simplify that, so I get 3x squared minus 16x plus 21. And I know that at a turning point, this is equal to 0. So I just need to solve that quadratic. And it looks like it factorizes. So if I put 3x here and an x here, and then 21 is 7 times 3, or minus 7 times minus 3. So yeah, if I do it this way around, that works. So x is equal to 7/3, or x is equal to 3. For each of these, I need to find the y value. Now, the y value for the second one is easy, because if I put x equals 3 into the function, I just get 0. If I put x equals 7 over 3 in, well, you could just do this on your calculator, but 7 over 3 minus 2 is a third, so I get y equals 1/3 multiplied by, and 7 over 3 minus 3 is minus 2/3, so I get that, which gives 4 over 27. Right, so those are the coordinates. Now I need to find the nature of them. How do I do that? Well, the easiest thing is just to do the second derivative test. So if I take this line here and differentiate it again, I get 6x minus 16. So let's put in the values of x. So when x was 7 over 3, this is going to give 42 over 3, which is 14, minus 16 is minus 2, and that's negative. And I know if the second derivative is negative, then it's a maximum. So I've got a maximum point at 7 over 3 and 4 over 27. Let's work out the second derivative when x was 3, the other turning point I found. So I've got 6 times 3, which is 18, minus 16 is 2. And that's greater than 0, which tells us that it's a minimum. So there we are. State the coordinates of the turning points of the curve y equals f of x plus 1 minus 4. So just need to apply some knowledge of transformations now. I know that if I add 1 to an argument, then that has the effect of moving everything to the left by 1. And then a minus 4 outside of the function, that moves everything down by 4. So the turning points, 7 over 3, that's moved to the left by 1. So 7 over 3 minus 1 is 4 over 3. And then 4 over 27 minus 4 is 4 over 27 minus 27 fours is 108. So this is minus 104 over 27. And the other point, 3 and 0, well, that's easier to do. 3 minus 1 is 2, and 0 minus 4 is minus 4. So those are the new turning points. Right, question 10. This is a modelling question. So we've got Zena putting a bucket of hot water outside on a day when the outside temperature is 0 degrees Celsius. Oh, it's freezing. She measures the temperature of the water after 10 minutes and again after 20 minutes. And this is her data. She's taken 2 data points. And she models it like so. So she says that theta, the temperature in degrees Celsius, is equal to A times 10 to the power of minus kT. First question, using t equals 0, what does the value of A represent here? So if I put t equals 0 in, I just get A e to the 0, so I just get A. So in other words, A represents the initial temperature, starting temperature. Right, second part is just doing some simple stuff with logarithms. So I need to take log base 10 of both sides of the equation. So log base 10 is equal to log base 10 A times 10 to the minus kT. I've got a product of A times the base 10 bit, so I can split that up into a sum of logs. And in the second term, the minus kT can come down to the front, and then I've got log base 10 of 10, which is 1, so I just got minus kT. There. Okay. log base 10 of 10 as well. So that just vanishes. Okay, which is what I'm after. Fairly standard. Part C, using Zena's results, calculate the values of A and K. Okay, so I just had, let's just write it down again, that log base 10 of the temperature theta is equal to log base 10 of A minus KT. So let's compare this with y equals mx plus c. Okay, so or minus k I should say, minus k is equal to the gradient. Okay, so delta y over delta x. The y values are the log base 10 of the temperatures. So that's going to be log base 10 of 30 minus log base 10 of 12. Okay, so this is my delta y divided by the change in the time, which would be on the x-axis if we drew a graph. So that's 10 minus 20, preserving the order as well. So I picked the 30 first, so I've got to pick the 10 first for time. That's going to give minus k. So if I just multiply everything by minus 1, I can swap the 10 and the 20 around on the bottom. And on the top, I can do 30 over 12 inside of a single log. So I just get that. And if I evaluate that on my calculator, 30 over 12 is 2.5. So log base 10 of that, and then divided by 10, I get 0.0398 roughly. Okay, so that's K done. Now, to find A, there are two ways to do this. Okay, I'll just show you them both. So one way is to just go back to this equation that we've got here, just substitute in all the values. So I can say log, if I just rearrange that for log base 10 of A, that's going to be equal to log base 10 of theta plus KT, and I'll just pick one of the values and the K that I just found and substitute it all in. So I can say log base 10 of 30 plus 0.0398 times 10. If I do it that way, I get 1.875, and therefore A, if I anti-log it, I get 10 to the power of 1.875, which if I've kept everything in my calculator and not just rounded off, I should find 75. That's one way of doing it. Another way, if you're thinking about what's actually happening here, is this is an exponential decay. Okay, the time is in the exponent, so it's an exponential decay. And what we know is that this is telling us that in 10 minutes, the temperature is going down by a factor of 30 over 12, so it's going down by a factor of 2.5. So if we go back 10 minutes to the start, then it must have dropped down by that same factor in the first 10 minutes. So the easier way to find A, remembering what that represents, is just 30 times 2.5, which is 75. Okay, so if you remember what these simple facts about exponential growth and decay, that it grows or it decays by a constant amount in set intervals, then you can use these shortcuts. Right, let's go back to the questions. 10D. Zena states that the temperature of the water will be less than 1 degree Celsius after 45 minutes. Does the model support that? Okay, well let's put in the values and find out. So theta was equal to 75 times 10 e to the, keep writing e, 10 to the power of minus 0.0398 times 45 minutes. So if you put that all together, you get about 1.2, which is greater than 1 degree. So therefore, it does not support the statement. And then finally, just a bit of thinking about the validity of the model. Explaining why Zena's model is unlikely to accurately give the value of theta after 45 minutes. Okay, so it could be that the temperature is not 0 degrees Celsius anymore 45 minutes later. It might have warmed up and got cooler. But also, from a practical point of view, this is the reason I'll put down here. She's only used 2 data points. That's not very good science. So she's not used enough data to accurately find K and A. Okay, so if she hasn't accurately found those, she can't possibly use that to find an accurate value for theta. Okay, and that's the end of the pure part. Now I'm going to do some statistics. Okay, so question 11. A survey is undertaken to find the most popular political party in London, and the first 1,100 people who were available were surveyed. So that's important there. The first ones that were available. I'll identify the name of this type of sampling. So this is just assessing your knowledge, really. This is opportunity sampling. Okay, it's not random because it could be that the people who have a particular political allegiance weren't available to be surveyed. So it's not a random survey, it's just opportunistic. Okay, the people were there, so they were surveyed. Okay, it's not the best type of sampling to do. Question 12. Manny is studying the price and number of pages of a random sample of books. He calculates the value of the product moment correlation coefficient, sometimes called Pearson's coefficient. The R value between the price and number of pages in each book is 1.05. Which of the following best describes the value 1.05? Well, what does this coefficient represent? So if you've got some data that's just random like that, R is 0. If you've got some data which perfectly lies on the line and it's a positive correlation, that's 1. If it is a negative correlation, they all lie on there, that's -1. And if it was something else, so it has a sort of positive correlation, but it's not as strong, then that might be, I don't know, 0.7 or something. But the important thing is that R is always between 1 and -1. So if he's found a value 1.05, that's definitely incorrect. It cannot possibly be outside of that range. Right, question 30. I'm not going to dwell too long on the first question, but in these stats papers, there's usually a question where you're now given a large data set, which you should have been familiar with through what you've done in class. So this one was all, in this year, in 2019, was all about cars with different types of propulsion. So is it petrol, diesel, electric, and so on. And a sample was taken of one particular propulsion type, and this is the carbon dioxide emissions from that sample. And basically what you should know from being familiar with the set is that having such a large range tells us that it's in category 8. Okay, I'm not going to say anything more about that. If you're unfamiliar with the data set, that will mean nothing to you. 13b, calculate the mean of the sample. Right, well, the mean of the sample, we just add up all the values and then divide by the number of values. So if we add those all up and then divide by 8, we get 72.375. Standard deviation. So what we do here is we take each of those values, subtract the mean, and square them. So we sum the squares of those, divide by n-1, and then take the square root. That's the standard deviation formula. So again, if we just apply that here, okay, if you've got a calculator that allows you to do statistics easily, this will be a lot quicker. I don't. So it took me a little while to calculate it, but I found I got 28.7. doing it like that. Right, question D. Denzel claims that the value 13 is an outlier. Any value more than 2 standard deviations from the mean can be regarded as an outlier, so verify that he is correct. Okay, so the mean was 72.375. The standard deviation was 28.7. So if I put that all together, I got 15. Okay, so therefore 13, which is less than 15, is an outlier. And state what effect, if any, removing the value 13 from the sample would have on the standard deviation. Well, if you're getting rid of the outliers, the values that are very far from the mean, then there's less deviation in the rest of the values. Okay, so the standard deviation will decrease. And if this is just a state question for 1 mark. So that's all you need to say. You don't have to explain it. Question 14. A probability distribution is given by this. So what this means is that the probability that a value is equal to x is given by this function when x is 0, 1, 2, or 3. So you're asked to show that c is 10. So what can you do here? Well, let's just work it out for each value. So the probability that x is 0 is when I substitute x equals 0 into that function on the right hand side. That's just going to give me 4c. The probability x is 1 in a similar way, c times 4 minus 1, so that's 3c, then 2c, then just c. And we also know that the sum of the probabilities must add up to 1. So 4c plus 3c plus 2c plus c is 100%. If you add those all together, you get 10c, so c is a 10. Okay, quite straightforward there. Calculate the probability that x is greater than or equal to 1. Well, that must be the probability that x is 1 plus the probability that x is 2 plus the probability that x is 3. So we got 3c plus 2c plus c, which is 6c. And c was 1 over 10, so that's 6 over 10, or 0.6. Okay, so 60% chance that x is greater than or equal to 1. Right, question 15. 2 independent events, A and B, are such that the probability of A is 0.2 and the probability of A, the union of that and B, is 0.8. What does this mean, union? Well, if we have a Venn diagram, in the left circle represents the probability of A, and the right one the probability of B, then the entire area of that whole thing is the union. So all the values that lie in either region. So first of all, find PB. Well, we know there's a formula that the union, the probability of the union of being in the union of A and B is equal to the probability that it's in A plus the probability that it's in B minus, because we don't want to double count, so minus this overlapping region in the middle, which has so that's the A and B, and that is just the product of those two events. So we can write that down. So let's just put in the values that we know. So this is 0.8, PA is 0.2, and then rearrange that. So 0.8 minus 0.2 is 0.6. And then on the right hand side we've got PB minus 0.2 PB, so that leaves 0.8 PB. Oops. So PB is 0.6 over 0.8, 6 over 8.75, 3/4. Okay, so what is the probability of A and B? Well, the probability of A and B is 0.2 multiplied by 0.75, which is 0.15. State with a reason whether or not the events A and B are mutually exclusive. They're not, because that's not equal to 0, right? Going back to the Venn diagram, if that region was equal to 0, that would mean that the two events were separate from each other. Okay, so there'd be no overlap. Okay, but we haven't got that case. That's not what we've got. We do have them overlapping. So because this region is not equal to 0. And then last bit is what we got, a hypothesis test. So Andrea is the manager of a company which makes mobile phone chargers. In the past, she found that 12% of all chargers are faulty. She decides to move the manufacturer to a different factory, and then she tests 60 of the chargers and finds that 4 of them are faulty. At the 10% level of significance, we want to find whether the proportion of faulty chargers has reduced. Okay, so we've got two hypotheses. We've got the null hypothesis, and the null hypothesis is that the probability was 0.12. And the alternative hypothesis, which we write H1 for, is that it has gone down, so less than 0.12. Okay, so let's write down the model that we're going to use. It's going to be a binomial model where we're testing 60 events, 60 charges, and we're looking at the proportion of 0.12, probability of 0.12. So let's work out the proportion that x is less than or equal to 4. What's the likelihood, the probability, that if you did that you would find 4 or fewer charges being faulty? Okay, and just be careful, it's not that 4 charges are faulty, it's 4 or fewer. So at this stage you would either use cumulative binomial distribution data from a table, or if you've got a calculator that does it, then that does statistics, which hopefully you've got if you're doing a statistics exam, then you would do that. I do not have a calculator like that, so I have to do it the long way. So the probability that x is less than or equal to 4 is the probability that it's equal to 4 plus the probability that it's 3 plus the probability that it's 2 plus the probability that it's 1, and then plus the probability that it's 0. And for one of these, for example, if I want to find the probability that's 4, the binomial distribution is that I would do 60, choose 4. Okay, so on your calculator you have a button that says NCR, which you'll probably have used when you've done binomial expansions as well. So 60 choose 4, and then multiplied by the probability P to the power of the number of events that we're looking for, which is 4, multiplied by 1 minus that proportion to the power of however many events don't have that. So 60 minus 4, which is 56. Okay, so hopefully you've got a calculator that does this all automatically. You don't have to work out every single term, but if you do, then so be it. Okay, and what I found anyway is after I do all that, I get 0.0787 for that one, 0.0404, 0.0154, 0.0038, and 0.0005, and that sums to 0.139. Okay, so that's a 13.9% probability. And we're investigating at a 10% level of significance. That's more than 10%. Okay, so it is not significant. So therefore, we should accept the null hypothesis. Okay, there's insufficient evidence. And then finally, part B, state in context. Okay, in this context of this problem, 2 assumptions that are necessary for the distribution that you've used in part A to be valid. Right. So first of all, you could say that the probability of a faulty charger is fixed. So at each factory, the probability at that factory is a fixed value. Okay, but this bit is important because the question says in a context. So you can't just say probability fixed. You have to say the probability of a faulty charger. So you have to refer to this context. And the other part is that they are independent. So one faulty charger is independent of another being faulty, which may or may not be true. If there was a sudden power shortage or problem with the machine at the factory, it may produce altogether a batch of faulty chargers. Okay, so it may not be that they are independent. But anyway, that's what we're asked to write down there. And that's the end of the exam. So if that was useful to you, then please like and subscribe. And if you want any one-to-one help with maths or physics or other subjects perhaps, then please visit my website www.physicsmathstuition.com and I'll try and help you out with that. Okay, bye for now everybody.